Yes, welcome to the video. Here I'll discuss about control chart for attributes. Actually, control chart for attributes is nothing but we are discussing about the characteristics or the qualities, whether it is good or bad or defective or non-defective, etc. So let us learn here. In this control charts for attributes, the sampled units are divided into two categories: defective and non-defectives. Defective and non-defectives. So defect in the unit. So definition for defect in the unit is given by: if a unit does not conform to specific quality standards, it is referred as defect in the unit. So here you please try to understand, defect is different from defective unit. So defect in defect in the unit is nothing but there is a means if you take any product, it is not meeting the standard quality of the requirements or the quality standards. The product is not matching with the standard qualities mentioned by the corresponding company and industries. So if you get any one defect or if you get any problem in one unit, particularly in one unit or one product, so it is regarded as defect. Okay, so if a unit does not conform to specific quality standard, it is referred as defect in the unit. Let us go with the defective unit. A unit which contains more than the permitted number of defects is called as defective units. The number of defected products are more in a unit is known as defective unit. Only the number is 1. So if one product is not meeting the standard requirements, then that is called defect in the product or defect in the unit. So if the number of defected items or defected products are more in a unit, it is regarded as defective unit. Okay, so once again you please go through the definitions. If a unit does not conform to specific quality standards, it is regarded as defect in the unit. And defective unit definition is: a unit which contains more than the permitted number of defects is called as defective unit. Then here the control chart, we already knows the control charts for variables. So we learned in control charts of variables, we learned two types of charts. One is X bar chart and the second one is R bar chart, mean chart and range chart. Here in control chart of attributes, here also we are learning mainly three. There are three types of charts. Control charts for fraction defective, P chart. Second, control chart for number of defectives, it is known as NP chart. Third one, control chart for number of defects per unit, this is C chart. So mainly here we are focusing on P chart and C chart. So once again, P chart is nothing but control chart for fraction defective, and C chart is control chart for number of defectives per unit. Okay, then let us understand what is a P chart. First of all, control chart for fraction defective. So fraction defective means, always you remember, P chart. Maybe in examination directly they will not mention P chart. So most of the times they are using fraction defective chart. So fraction defective chart means you always remember it is P chart. So here P chart is designed to control the proportion of defectives per sample. The distribution of P chart follows the binomial distribution. Here you mainly need to remember two major formulas here. P chart formula, that is fraction defective, P is calculated by the formula D by N. So here D is nothing but number of defectives in the sample, defective attributes in the sample, and N is size of the sample. So this is P value, P is equals to D by N. Similarly, you can also calculate P bar value. So in statistics, for the P chart is the mean fraction defective. P bar, mean fraction defective. Fraction defective means P is the symbol, mean fraction defective means P bar is the symbol. So P bar is calculated by using the formula P bar is equals to number of defectives in all the samples divided by total number of items in all the samples. Okay, this is the formula to calculate P bar value. Here P bar acts as a control line, CL value. Then to calculate UCL and CL values, means for construction of P chart we are having a steps here. First step, calculate P bar. So P bar value, by using this formula we are calculating P bar value. In step 2 we are calculating standard error, so sigma P value. So standard error sigma P value we are calculating by using square root of P cube by n, or you can also use square root of P into 1 minus P divided by n. Both are applicable. Then in third step, compute the control limits, or UCL and LCL value you need to calculate. To calculate UCL value, if they are giving P value directly in the problem, then you are using this formula. UCL is equals to P plus 3 square root of P into 1 minus P by n is the formula to calculate UCL. Similarly for LCL, LCL is equals to P minus 3 into square root of P into 1 minus P by n. So this is LCL formula. So if P value is not known, if they are not giving P value directly in the problem, then you need to use P bar in place of P. So here you are having one more set of formula to calculate UCL and LCL. LCL is equals to P bar plus 3 into square root of P bar into 1 minus P bar by n. Similarly LCL is equals to P bar minus 3 into square root of P bar 1 minus P bar by n. So these two formulas are applicable when they are not giving P directly in the problem. Okay, so now let us see how to find P bar chart. Okay, control chart for fractional defective. So first example, the following values given will give the number of defectives in 20 samples containing 2000 items. Okay, containing 2000 items. So they are given here some of the samples, total there are 20 samples. Okay, 20 samples they are given containing 2000 items. Okay, calculate the values of control line and control limits for P chart. So directly they are asking here to calculate CL control line and control limit. Control is limit nothing but UCL and LCL value for P chart. Here luckily they mentioned P chart. If they are not mentioning P chart, they will mention fractional defective chart. You please remember. Then let us proceed with the solution here. Total number of items in 20 samples, capital N is equals to 20 into 2000 gives 40,000, because you need to calculate total items, total number of items. To calculate total number of items in 20 samples, you are using this capital N indicates the total number. Okay, total number of items. So here total there are 20 samples they are given, 20 into total 2000 gives 40,000 total number of items. Then total number of defectives in 20 samples, summation D you need to calculate. Summation D you are getting this value by adding all these defective values in the given data. Whatever the data they are given here, you add all the data, therefore you are getting 6148. Then mean fraction defective, P bar is calculated by summation D by capital N. Summation D value is known, 6148 divided by total number of items is 40,000. Then here you are getting 0.1537. So 0.1537 is your P bar value. So when you get P bar value, then you go for control limits, means to calculate UCL and LCL value. So to calculate UCL value, formula is P bar plus 3 into square root of P bar into 1 minus P bar by n. Similarly to calculate LCL, P bar minus 3 into square root of P p bar minus 1 minus p bar by n. Here p bar value you calculated 0.1537, n value, capital N value is 2000, right? Here, sorry, small n value is 2000, means number of samples here, because capital N value you are calculated 40,000, here small n value is 2000, you please don't confuse. Then CL value, so your p bar value acts as a CL, solid line, 0.1537. then if you calculate with the help of these two formula, your UCL value is 0.1779 and LCL value is 0.12952. Here no need to draw any chart, because they are asking to calculate only the control line, okay, values of control line and control limits. So value of control line is 0.1537 and control limits, UCL value 0.1779 and LCL value 0.12952. okay, in next video I am going with the second example. Please keep watching.